Assalamu alaikum wa rahmatullah. Hi everyone. We are at question 17 from the file of the first question. We have a graph of the velocity and a table of t values and v of t. The graph of the velocity in feet per second of a car traveling on a straight road. The interval goes from 0 to 50. It's shown above, and also a table of values for v of t at 5-second intervals of time is shown as well. During what intervals of time is the acceleration of the car positive? Well, the acceleration right, is positive when v of t is increasing, right? The acceleration is going to be positive, okay? This is when the velocity is increasing. Well, the velocity here, it's increasing 0, 12, then 20, 30, 55, up to what? Up to 81. So this one goes from 0 to 35. So the first one is from 0 to 35. And then it's increasing again 60 to 72, from 45 to 50. From 45 to 50. You can also find the answer from the graph as well. Find the average acceleration of the car in feet per second squared over the interval 0 to 50. Well, the average acceleration is going to be v of 50 minus v of 0 over 50 minus 0. And both values, v of 50 and v of 0, are given in the table. So the acceleration will be 1.44. The unit is feet per second squared. This is question 17 and 18. Question 19. It says a particle moves along the x-axis so that its velocity is given by v of t. The particle is at position x equals 8 at t equals 0. Find all times t in the open interval at which the particle changes direction. During which time interval does the particle travel to the left? Well, in this question, we need to find where is the particle at rest first by setting what? V of t, which is ln of t squared minus 3t plus 3 equals to 0. Okay, we know that ln of 1 equals to 0. This is fact, right? ln of 1 equals 0. That means this business over here, right, should equal to what? Should equal to 1. So you have to set them equal to each other. T squared minus 3t plus 3 equals 1. Minus 1 on both sides. T squared minus 3t plus 2 equals to 0. So you get the t values now. The t values are going to be 1 and 2. 1 and 2. Now what's happening to the sign of what? Sign of v of t. We know that we are starting at 0 up to what? Up to 5. There are 2 t values in between, 1 and 2. Right? You check the sign. If you choose, for example, a value between 0 and 1 and check the sign of v of t, the sign of v of t, it will be positive and then negative and then what? Positive. So it change direction at 1 and at 2 because it goes from positive to negative and then from negative to positive. So it changes direction. Here it changes direction at t equals 1 and t equals 2. During which time interval does the particle travels to the left? Well, here. The particles travel to the left for t's between 1 and 2 because the velocity is negative. Moving on to the next questions. A particle moves on the x-axis so that the position is given by x of t. Find the acceleration at t equals 0. Well, we have 2t to be first and the exponential to be the second. So the acceleration, differentiate the first, leave the second, plus leave the first, differentiate the second. Right? Now, this bracket is extra. We can rewrite it. A of t equals, well, there is e to the power of minus t as a common factor. That leaves me with 2 plus or minus 2 minus 2t, right? 2 minus 2t, right? Are we on the right track? This is e to the power of minus t taken as a common factor. You've got 2 and then you've got 2t, right? Okay. You are looking at the acceleration at 0, e to the power of e minus. Why do I feel there is something wrong here? Let's figure it out. Okay. What is the mistake we've done here? That what we are doing is not the acceleration. This is the velocity, right? This is the velocity, right? This is the velocity. We found the velocity. Now we can differentiate again to find the acceleration, right? So A of t is, again, this is the first, and the whole bracket is what? The second. Differentiate the first, leave the second, plus leave the first, differentiate the second. Now for A of t, we can factor out minus e to the power of minus t. That leaves us with what? 2 minus 2t plus 2, which is minus e to the power of minus t, and then you've got 4 minus 2t. This is the acceleration. You need what? You now A of 0, plug in the 0, minus e to the power of, well, there is no minus 0 here, okay, just delete the minus, bracket 4 minus 2 times 0, and this simplifies to minus 4, I guess. This simplifies to minus 4. This is the acceleration, right? This is minus 4. This is question 20. Question 21 says, find the velocity of the particle when the acceleration is 0. Well, we found A of t to be what? Just did it. Minus e to the power of t, bracket 4 minus 2t. If you set it equals to 0 as it says here, this one is never 0, but this one can be 0, and if you set it equal to 0, t will be equals to what? To 2. Now let's find d of 2, which is 2 times 2, no, let's use this one, okay? It will be what? minus e to the power of minus 2. There is no minus. There is no minus. Times what? 2 minus 2 multiplied by 2. Well, as a final answer for the velocity, well, it's going to be negative 0.271. This is question 21. (22) says we are given v of t, find the acceleration at t equals 2. So it's a calculator active. So to find a of 2, use your calculator, type d over dx of, I'm replacing x with t with x, so this is x plus 1, just to match your calculator format. Sine of x squared over 2, this is at x equals 2. You should get 1.587. Okay, you need v of 2 now. By the calculator as well, v of 2 should be, it will be negative, right? If you use this one to find v of 2, it will be what? Negative. And because the acceleration is a of 2 is what? Positive. V of 2 is negative. So this, so what do we say? We say that the speed is decreasing, right? Because they have different signs. Speed is what? Decreasing. 23, find the acceleration at t equals 7.5. This is the velocity. So v prime of t gives us that acceleration. We are interested at 7.5. We will be finding what? The slope, which will be what? V prime of 7.5. We're going to use this point here and this point here. This point is 8, 0.2. This point is 7, 0.3. So this is going to be what? 0.2 minus 0.3 over 8 minus 7, which is negative 0.1. What's the unit? Miles per minute squared, right? Miles per minute squared. Because the slope is the slope of the velocity graph will be the acceleration, right? Question 24. There are two runners. Runner A is given, and the velocity of runner A is given by the graph. The velocity of the second runner is given by v of t. Okay? For runner A, we need to find the acceleration of runner A at 2. Well, at 2, you will use this point and this point. This is 0 and 0, and this is 3 and 10. So it will be 10 minus 0 over 3 minus 0. Because the acceleration is the velocity, the slope of the tangent line for the graph of the velocity. So this is going to be what? 3.3 repeated, right? Meters per second squared. Now, for the second particle here, A of t, you will use the quotient rule. The quotient rule says the denominator, okay, times the derivative of the numerator, which is 24, minus the numerator, which is 24t, times the derivative of the denominator, which is 2, divided by the denominator squared. And then plug in the value, which is 2. Right? Plug in the value, which is 2. You must get 1.469 meter per second squared. Question 25 and 26. Is the particle moving toward the left or the right at t equals 1? Well, let's find v of t, which is given by 15t squared minus 18t plus 0. And then let's find v of 1. 1 squared minus 18 times 1, which is negative what? 3. So the answer will be what? Toward the left. Okay? A particle moves along the x-axis and the velocity is given by this function. During what intervals of time is the particle moving to the left? Well, we have to set the velocity equal to 0 to find where is the particle is at rest. E to the power of 2 sine of t, right, minus 1. Set it equal to 0. If you set it equal to 0, what happens now? Well, you have to add 1 to both sides. So e to the power of 2 sine of t equals 1. ln on both sides. So 2 sine of t equals to ln of 1, which is 0. ln of 1 is 0, right? ln of 1 is 0. Divide both sides by 2. Sine of t equals to 0 over 2 is 0. The interval we are interested in is from 0 to 16. Now on this interval 0 to 16, the t values will be what? Sine of pi is 0, sine of 2 pi is 0, sine of 3 pi is 0, sine of 4 pi is 0, sine of 5 pi is 0. But if you go for sine of 6 pi, it will be more than 16, right? So we'll stop at 5 pi. Now let's check the sine of what? The sine of, let's do it down here. Let's check the sine of v of t. We are starting at 0 all the way to what? To 16. We have pi. Okay, we have 2 pi. We've got 3 pi. We've got 4 pi. We've got 5 pi. Okay. Because 5 pi, it's 5 times 3.14. It's less than 16. Let me just double check what 5 pi is. 5 pi is approximately 15.7, which is less than 16. Now choose values in between. Okay. How do we choose values in between? Well, we know that this value is 3.14. Okay, so choose a value less than this one, like 3, and check the sign of the given velocity. It will be positive. It will be positive. Okay, now choose a number between pi and 2 pi, like between 3.14 and 6.28, like 4 or 5. It will be negative. Okay, and then positive, and then negative, and then positive, and then negative. I am assuming you can check all the intervals, okay? Just replace pi with 3.14 and select test points in between. The question says moving to the left, during what intervals is the particle moving to the left? Well, the particle is moving to the left here, and here, and here. So the first one is pi to 2 pi, and then 3 pi to 4 pi, and then the last one is 5 pi to 16. 5 pi to 16. Because the velocity is what? Negative. That's it for the first file. I wish you all the best, everyone.